Okay, this video is going to teach you how to simplify square roots. So what we've done so far is we've taken square roots of perfect squares. So a square root of 25, for example, is 5. 25 is a perfect square. It comes out nice and neat. Or you would find a square root of a number and you would approximate it to the nearest tenth, or you would round it to wherever it asks you to round it to. Now what we want to do is simplify square roots. The difference here is that there are three conditions that need to be met in order to ensure that a square root is simplified. We're going to be dealing with numbers that are not perfect squares. So in order to ensure that a square root is simplified, or in simplest form, you have to first make sure that there are no factors under the radical sign that is a perfect square. That's the first thing, other than 1. So, for example, if I wanted to find a square root of 25, that is a perfect square, and I would take it out, and it would be 5. But if I wanted to find a square root of 24, what you would do is you would break that up. What are the factors of 24? What multiplies together to give you 24? And you could do 4 times 6. Well, 4 is a perfect square. You would pull that part out. Okay, that's what that part is saying right there. The next one, you can have no fractions under the radical sign. And the last one, no radical sign in the denominator of the fraction. So these are the three conditions that must be met in order to ensure that you have a simplified square root. All right, well, the question is, and how do you do that? Well, there's two properties that I want to go over with you. The first one is the product property. Of square roots. The product property of square roots says that if you have two numbers that are being multiplied together. So, for example, I did the 24 earlier as an example. If 24 is the same thing as 4 times 6. What you could do then is you could say, all right, well, I could take the square root of that 4 times the square root of that 6. That's what the product, I wrote 6, it should be B, sorry. That's what the product property tells us. All right, I have a square root. I could break it up into factors or numbers that multiply together to give me that number. And then I could break that into two separate radicals. That's a handy rule. Now, an example, again, I just said the 24. So if I did this, 24 is the same thing as the square root of 4 times square root of 6. You would do square root of 4 times square root of 6. Okay? Now, when you do that, what you're trying to do is you're trying to break this up so that you have, under one of the radical signs, you have a perfect square. And I do. I have 4. So I take the square root of 4, which is 2, times the square root of 6. Now what I did is I simplified it, and I used the product property to simplify it. You could also do this if you have, let's make this more interesting, square root of 24, and now I'm going to say x squared. All right, well, again, this is not something you can enter in your calculator, but you can use your product property here in order to solve this. The way that you would do that, say, all right, well, this is the same thing as the square root of 4 times 6 times x squared, which is square root of 4 times square root of 6 times square root of x squared. We can do the square root of 4, which is 2. We can do the square root of x squared, which is x. It'll be times square root of 6. So what we did is we just broke all that up, and then we separated it into separate radicals. We took the square roots of the ones that we could. The next one then is the quotient property. Okay, the quotient property of square root says that if you have the square root of a fraction, you could split this up so you have the square root of the numerator over the square root of the denominator. An example of how this would be useful, let me give you the square root of 32 over x squared. So first thing, quotient property says that I could do this. Square root of 32 over square root of x squared. Square root of x squared we know is going to be just x. The square root of 32, well, that one doesn't come out evenly. But what we can do is we can break this up. And now we can use the product property in our numerator. So I could say, all right, well, how do I get 32 through multiplication? I could do 4 times 8, and I could take the square root of 4. But then I would have to do that again to 8. I would have to make 8 2 times 4. If I looked for the largest perfect square, I would say square root of 16 times 2. 16 is the largest perfect square that goes into 32 over x. This is the same as square root of 16 times square root of 2 over x. Square root of 16 is 4. What's left is square root of 2 over x. That's a lot of work. That's simplified. And it follows the 3 conditions. There's no factor under a radical sign that's a perfect square. All we have is the 2 underneath there. There's no fractions underneath the radical sign. There's one in the numerator, but that's no big deal. And there's no radical sign in the denominator of the fraction. So this is simplified. No, it's a lot of work, but it's kind of fun too. You got to admit it. Let's try some other samples, shall we? All right, I'm going to give you square root. I'll give you an easy one. This is for you to try on your own. Square root of x over 64. Go ahead and pause the video and try that one. Okay, for this one, the first thing you should have done is the quotient property. Square root of x over square root of 64. We cannot do the square root of x, so it remains up here. Square root of 64 we can do, and it's 8. Very simple one. It meets the 3 conditions. There's no factor under the radical sign that's a perfect square other than 1. There's no fractions under the radical sign, and there's no radical sign in the denominator. So that is done. It's fully simplified. All right, let's try one that's a little more complex. Try this one. And again, pause the video and try this yourself. Square root of 28x squared over 9. So pause the video and try this one. Okay. So for this one, again, the first thing I'm going to do is this. 28x squared over square root of 9. That's my quotient property, because I could separate that. Then I could do the square root of 9. It's 3. Up on the top, I'm going to have to break this up. So I'll say square root of 4 times 7 for the 28 times x squared. This is equal to the square root of 4 times square root of 7. Now I'm using my product property in the denominator. Numerator, sorry. It's been a long day. Over our times x squared all over 3. Square root of 4 I can do. That's 2. Square root of x squared is x. Then times square root of 7 all over 3. Now, there is another method to do these. And I want to show this one to you because this is a great method when the numbers are large, like they might be on your test, for example. Hint, hint, wink, wink. All right, so, or I'll write down, you could do this. The square root of 28x squared over 9. this number, 28, is very easy to pull out a perfect square. When the number is really large, it's not. What you could do is you could split this up. Use your quotient property like normal, but then underneath the radical sign, I want you to write down the prime factorization of 28. Prime factorization of 28 is 2 times 2 times 7 times x times x. Well, I should say 28x squared all over square root of 9. Square root of 9 is 3, like we know. Then what you could do is you can look for pairs. Here is a pair. Here is a pair. When you see a pair, one of those comes out because 2 times 2 is 4. The square root of 4 is 2. So I would pull that 1, 2 out. X times x is x squared. Square root of x squared is just x. I'd pull 1x out. What's left in the top? Square root of 7. That's another method. Again, it's a great method when the numbers are large. I don't care which one you use. But let me give you one that's a little bit bigger. Not that bad, but try this one. Pause the video and do that one. Okay, I'm going to solve this one both ways. First, I'm going to do this. The square root of 2 times 16 times x to the 4th times y to the 2nd times z. This is equal to the square root of 2 times the square root of 16, this is using my product property, times the square root of x to the 4th times the square root of y squared times the square root of z. Whew, that's a big one. Now, square root of 16 is 4. Square root of x to the 4th is x squared, because x squared times x squared is x to the 4th. And the square root of y squared is y. Times what's left? I have 2 and I have a z. Okay? Or my other method, so if you take this, some students really prefer this method. I really don't care which one you prefer. And you write the prime factorization. It's going to be long. 32 is going to be 2 times 2 times 2 times 2 times 2. Then you have times x times x times x times x times y times z. And you're going to look for pairs. Here's a pair, here's a pair, there's a pair, there's a pair, there's a pair. And you're going to pull those pairs out. So I have 2 times 2, because again, you're only pulling out 1, 2 from the pair. 2 times 2 would give me 4 on the outside. Then I have x times x would give me an x squared. And then I have a y on the outside. Times the square root of what's left? 2z. The most common student mistake when doing this is to take, for example, this y squared, y on the outside, or on the inside of the radical sign there, and making it y squared on the outside. You don't want to do that. You find a pair, you're pulling just one of them out. Alright, so if you're going to use this method, make sure you understand that. And the last thing is our daily puzzler. Again, this is just for fun. It's not homework, but if you want to try this, go ahead and try it. This is going to be a compound fraction. I want you to simplify this. 9, square root of 9, over the square root of 16 over the square root of 64. A little hint with this. If you cover up the square root of 9 with your hand, look at the denominator as just a fraction itself, figure out that, then figure out the rest of it. It's a little clue for you. That is all. Have yourself a great day, everybody. Bye-bye now.